Okay, we were talking about subtracting two vectors at the very end of the last video. So let's go back to that. If these are my vectors v and u, and I wanted to do v minus u, then that's the same as doing v plus negative u, right? Just multiplying u by -1. It's the scalar multiplication of u by -1. And so if my vectors are u, here's u, and here's my vector v. So my vector v is here. If I wanted to do v plus negative u, I would start at the tip of v and then add to that negative u. So this would be negative u, and so then my resultant would be there, which would be v minus u. So you're still doing tip to tail. It's just that you're taking that second vector and switching the direction of it because of that minus sign. Okay, so that's the idea behind that. Okay, let's talk about vectors in the rectangular coordinate system. We were talking about the rectangular coordinate system when we were talking about polars, but now we're going to talk about it in terms of vectors. So if this is 1 right here, and here's 1, this is your x-axis, this is your y-axis, then this unit here along your x, that is the unit I, and then your 1 unit along the y-axis is j. Okay, so I is the unit vector along the positive x-axis, j is the unit vector along the, I is the unit vector along the positive x-axis, j is the unit vector along the positive y-axis. Okay, unit vector meaning it's just 1 unit. So if I had any other distance, so let's say this was a, then this distance right here, if that line were totally straight, would be ai, which is just a times I. So a is the scalar multiple of I. And then if you had if b was here, then this distance here would be bj. So b is your scalar multiple of j. And so the vector where these two meet, so if I did my addition, just like we were doing before, if I did that tip to tail, if I move this bj over here, right, and put that there, then my resultant would be this here, and that would be ai, ai plus bj. Okay, so as soon as you apply some scalar multiple to that, that just changes the magnitude of the vector, but it doesn't change the direction. So when we're representing vectors in rectangular coordinates, we're always measuring from the origin, or from 0, 0, okay, to some point A, B. So in that previous example, right, this point right here is the point A, B, if you think of it that way. And so if I have the vector v from the origin, from 0, 0, to the point AB, my vector v then can be represented as ai plus bj. So a is the horizontal component of the vector v, so horizontal component, and b is your vertical component of the vector v. Okay? If you think of it as ai plus bj, as the linear combination of I and j, right? It takes those two, the horizontal and that vertical vector, and combines it into one vector. Then our magnitude of v, of our vector v, then is just going to be, right, if you think about Pythagorean theorem, a squared plus b squared, right? So if you think about it, here's your vector. This is ai plus bj. This distance here is b. This distance here is a. So I can find the magnitude of that by just doing Pythagorean theorem. Let me show you an example of that. So it says sketch the vector negative 3i plus 4j and find its magnitude, or find its position vectors. Okay, so negative 3, that would be negative 3 in the x direction, 4 in the y direction. So from 0, 0 to that point, that is my position vector, right? My initial point is always at the origin. And so this distance here is 3. This distance here is 4. And so I can find its magnitude by just doing the square root of 3 squared plus 4 squared, which would then give me 5. So it's pretty straightforward when you think of it from that standpoint. Then on the last page of your notes, we're talking about a vector v with initial point P1 and terminal point P2 is equal to the position vector. So now let's say I'm taking some vector anywhere. It doesn't necessarily have to have its initial point at the origin. I'm just taking this vector. Okay, and it's always going to be equal to, remember, I is your horizontal component, j is your vertical component. So if you just take the difference of the x's and the difference of the y's and put them in the right places, you're going to get your position vector. Let me show you an example of that. We've got P1 and P2 given here, and it says write the vector v in terms of I and j. So I have my x's and I have my y's. So negative 2 minus 3i plus 5 minus negative 1j. And so then my vector v in terms of I and j is just negative 5i plus 6j. And there you have it. That's pretty much everything, as far as the basics go of vectors. Remember, the I and j, you've pretty much dealt with those before. You just didn't know it, right? Your I is your horizontal, j is your vertical. This I is different than the imaginary I, so don't let that throw you off. But just that we have those two different components. Magnitude is just the distance formula, or think about it as Pythagorean theorem. Okay, that's pretty much it. That should help you get through the assignment for tonight. I'll have another video for you guys tomorrow. Have a great rest of your day, everybody. Take care. Bye-bye.